Hello and welcome to Solving Radical Equations. What we're working on today is combining the ideas of what we've been doing with simplifying radicals and actually solving equations. Everything that you've had up to this point didn't have equal signs in it. Now we've got an equal sign, so we're actually going to try to figure out what some of these variables are. We couldn't do that before because we didn't have an equal sign, but if you have an equal sign, you're able to solve. So, two major steps when you're solving these equations. Before that, label your notes with your section and your essential question, how you can solve a radical equation. Hopefully you're getting in that good habit. Your steps for solving is you want to try to isolate the radical. So like solve a regular equation, but you are trying to get the square root of x, as you can see in this first example, by itself first, rather than just trying to get x. Now you got to get square root of x by itself. Next, you're going to square both sides of your equation. And then you should be done. There might be a couple extra steps after that. So in our first example right here, I've got the square root of x minus 3. So my first thing is I want to get rid of this minus 3 right here. I don't want that there. I want to get rid of it. So my very first thing I want to do is I want to add 3 to both sides of my equation so I can isolate that square root of x. So I get the square root of x equals 9. Now I can square both sides of my equation. The reason I want to do that is square and square root are considered inverse operations. They're operations that undo each other. So if you square a square root, that removes that square root. Just like if you add and subtract 3, those are inverse operations. So we want to get rid of that radical, we use the inverse operation, just like we add 3 to get rid of a minus 3. Now keep in mind, anything inside of the square root doesn't change. You're just going to change the fact that there's a square root there, because that's gone. You're left with just an x. The other side, however, will change. We've got 9 squared, that's 81. And you can check to make sure that this works. We get, if you put it back in, we get the square root of 81 minus 3 equals 6. The square root of 81, that's 9 minus 3. Yep. 9 minus 3, 6 equals 6. We're all set. That works out. Okay. Now, this next one, we're going to have to do a little bit more work in order to try to get that radical by itself. We've got a minus 8 and a 2. Just like you would if this was 2x minus 8, you would get rid of the minus 8 first and then the 2. We're going to do the same thing here. We want to get rid of that minus 8 first, so we're going to add 8 to both sides. Ew, that's an ugly plus 8. Let's clean that up. All right. Add an 8 to both sides. We get 2 square roots of x equals 8. And now just as if this was 2x, you would divide both sides by 2. We're going to do the same thing. The fact that there's a square root doesn't change any of our solving steps as we try to isolate that radical. Nothing happens to that radical x because it's inside of that radical. You can't do anything to the x. Now we want to use our inverse operation again. We want to get rid of that radical. So to get rid of it, we use our inverse operation, which is squaring. So we square both sides. Squaring a square root, all that does is remove the radical. And we're just left with an x. When we square 4, we get 16. And then we're set. We can double check it real fast. I might as well do that. So we got 2 square roots of 16 minus 8. This should equal 0. The square root of 16, that's 4 times 2 minus 8. 2 times 4 is 8 minus 8. Hey, 0 equals 0. We're set. Awesome. Next. This one has got even more stuff going on. Now there's something going on inside of the radical. And you might think, ooh, is there something different we're going to do? Yes, but it's not until the very end. Everything inside of this thing is locked. You cannot mess with anything inside of that radical. So don't worry about any of the operations that you're going to be doing. You're going to be tempted to add 7, but it's stuck inside of the radical. We can't get rid of that 7 until we get rid of this radical. We can't do anything with this radical until we get rid of these two numbers. So let's get rid of those first. So I'm going to subtract 12, get 4 radical x minus 7 equals 16. We want to get rid of that 4, so we're going to divide by 4, and we get 4. Now, keep in mind what I've been saying. Anything inside of this radical is locked. We cannot do anything with it. So we square root x minus 7. Then that's it. You can't do anything else. All that happens with this is these two 4s are canceled out. That's it. You don't do anything to the 7. We still can't do anything to the 7 because it's being square rooted. So we need to get rid of that. So to get rid of that, we're going to square both sides. And squaring a square root, all that does is gets rid of the radical. So we've got x minus 7 equals 16. Now, this looks like an equation that we solved back when we were in algebra. Well, we're still in algebra. Back first semester, we just got to get rid of that minus 7. So we're going to add 7. So x equals 23. And we're done. We can double check that really fast. I'm just going to pop it up. There we go. So I plug in the 23. 23 minus 7 gets us 16. I square root this 16 and we get 4. 4 times 4 is 16 again. And then the 16 plus 12 is 28. So that works out nicely. Our answer is great. We'll move on to the back. I might have a video break here.